uh, two discussions. Part one will be on Hyperledger Fabric chain code life cycle. And in part two, we will be talking about secure multi-party computation and how it can be used for the security in blockchain for blockchain applications. So as we saw yesterday and today, that Hyperledger Fabric gives you a wonderful environment for creating enterprise level blockchain networks where the consensus mechanism is different. Here, the structure of the network is different. People have different roles. Every node has a different role. And all those, every single business logic is defined in terms of a smart contract. All the smart contracts are bundled in a what is known as chain code. So in this session, we will be talking about chain code life cycle management, and then, as I told, secure multi-party computation. So let's begin with part one, chain code. So a smart contract defines the transaction logic, right, that controls the life cycle of any business object contained in the world state in a Hyperledger Fabric network. So by business object, as we know, any business object could be, for example, if it is the application is for healthcare, then the business object could be medicines, the business object could be diagnostic, the business object could be the medical records, depending upon what kind of business we are running on this blockchain network. So accordingly, every smart contract defines the transaction logic and the life cycle of every business object. So if it is, for example, the medicine to be provided to certain person to a patient, it has a life cycle. The medicines are generally provided for, say, 1 week, 2 weeks, 1 month. So it has a life cycle. Accordingly, how these are managed. Okay, so smart contracts are packaged into a chain code, which is deployed to the blockchain network. Today, we shall see how this is deployed to the blockchain network. And then in the next lab session also, you will see that how we can use the smart contracts or the chain code to run a business on your test network. So smart contracts govern transactions, whereas chain code governs how smart contracts are packaged for deployment and how they can be used. That is the idea. Okay. So chain code implements a prescribed interface. So whenever I say that there are several smart contracts within a chain code, then for accessing each smart contract, you should have some interface. So basically, chain code also has an interface to interact with the smart contract. Okay, so now, so chain code is written in Go, Node.js, Java. In Python also, developments are being made so that APIs are made available. And chain code runs in a secure Docker container. You just, in the morning session, you saw how Dockers are installed. So Docker container basically isolates different things, and to make it a secure place so that no tampering can be done. So chain code runs in a secure Docker container isolated from endorsing peer process. And chain code initializes and manages all the ledger state through all the transactions submitted by application. So what happens when a transaction proposal is submitted. There is some smart contract within a chain code that will be called. So once that smart contract is invoked, how the endorsement policy is to be checked, whether the transaction proposal is having right kind of signatures. All these things will be maintained and verified through some kind of logic that is there written in a smart contract. So chain code initializes and manages all the ledger states through the transactions that are completed through the smart contracts, right? So it can also be used for low-level system programming, because in order to maintain the network, you need not always be doing from the client application sides. There can be many things that need to be managed at the network side. So low-level system programming, for that also you have chain code. So such type of chain codes are known as system chain codes. So remember that there are system chain codes and there are application chain codes. Those application chain codes will be installed on different peers. So let us consider how smart contracts are bundled in a chain code. For example, if it is a vehicle chain code, vehicle could be car, it could be boat, it could be scooter, it could be truck. So any kind of, if it is related with car, then how the car contract will, what will be the logic for business using the car object or boat object or truck object. For them, they can be different contracts. Similarly, insurance chain code, if you see on the right side here, this insurance chain code can be policy contract, can be liabilities, can have syndication, can have securitization. There can be many things that are there in the insurance chain code. So all business corresponding to insurance can be specified in terms of several contracts. So that is why we can say that this is a modular kind of design, where there can be separate contract for each of the functionality and for each of the object. Okay, this is how it happens. So a smart contract is defined within a chain code, and there can be several smart contracts within the same chain code, as I showed you here. So when a chain code is deployed, all the smart contract within it are made available to the application. Okay, so chain code is deployed on a channel, on a network. Accordingly, everything is made available. Now, how do we define the endorsement policy? See, on the left-hand side, you have a car contract, for which the endorsement will depend on the type of business that we are running with car object. And therefore, it may happen that several people may be involved in endorsing some proposal. Whereas in insurance, if it is a policy contract, it will be an endorsement between two parties, right? And policy has to be accepted. Generally, the companies accept the policy based on the whatever terms and conditions are there. If we agree, then policy will be accepted by the company. So accordingly, that is what is done. I mean, everything is made available to the application. So, and associated with every endorsement is an endorsement policy. I don't know why it is showing too much. Just give me a minute. I don't know why it has shifted. Give me a minute. Yeah, here it is shifted by mistake, perhaps. Yeah. So associated with every chain code, remember that there is an endorsement policy that applies to all the smart contracts defined within it. So, for example, endorsement policy for car, for boat, for truck, whatever is the endorsement policy, that is very clearly defined in the chain code. Okay. So an endorsement policy indicates which organization in the blockchain network must sign a transaction. So if you remember, I told you that there are some endorsing peers. So those endorsing peers of different organizations will be signing on the contract or signing on the transaction proposal, provided they have a role. In case of insurance contract, not many endorsing peers may be having roles. If it is between two parties, it will be signed between two parties. Okay. So let us take this example of a seller organization and a buyer organization, where the application it has called, like, there has to be some seller and buyer. So you have seller is org1, organization 1, buyer is org2, and there is a transfer of an asset. It is an asset, car 1, from seller to buyer. And this car contract, let's first begin with the query, car, get car query, like return car. There can be one query in the contract, one query function. There can be another function that is transfer the ownership. So car, buyer, seller, get car, car owner is equal to buyer, put car, and so on. So similarly, update car properties. So this update can be another function where I would like to change the color of the car or whatever. And then there is a car interface here. You can see there are two organizations, the buyer organization, the seller organization. This is the application which knows that there are two parties in it. And this interface to this smart contract is provided by the chain code, where there can be several transactions like query, transfer, or update. And the endorsement policy, I seek your attention please here, that the endorsement policy says that both the organizations must sign the proposal, transaction proposal. That is, buyer is ready to buy and the seller is also ready to sell. Okay. So endorsement policy here is important. Now, here I show you that this is a seller organization. This is the car interface. Now you have a car contract. You have a car transfer transaction that is taking place. So identifier here is T3. This transaction T3 is the identifier of this transaction. The proposal here is input car1, org1, org2, signature of this, and then response. So you can see that the output signed by org1 and org2, both the people have signed. So third, this current car, where the owner is now org2, right? So you can see here that this ledger, all these transactions are recorded in the ledger, and the corresponding world state is also changed, right? So seller was org1, the buyer was org2. So because org2 has become the new owner, so you can see that now the owner becomes org2, right? So what I intend to tell you here is that all transactions are recorded, but only valid transactions change the world state. So all transactions are recorded, right? Because it may happen that I initially think of purchasing and give an advance of, say, some rupees 3 lakh, and then I don't intend to do that, then I get my return value. So in that case, this transaction is not fulfilled, but this is all recorded here, right? So what kind of transaction is put here across? The ownership is not changed. All right. So Chain code initializes and manages ledger state through transactions. You know that every ledger state will be changed if the transaction is completed successfully and some change has occurred in the state. So remember that scope of a change in a state by chain code is exclusively to that chain code. You cannot access one chain code directly by another chain code. Remember that every chain code will be secure. So it is not possible to create a chain of all chain codes that can be invoked by keeping yourself within a Docker of one chain code. So scope of a state created by a chain code is exclusively to that chain code. But remember that sometimes one function call invokes another function call, and that function call could be from another chain code. So a chain code may invoke another chain code to access its state within the same network if the permission is provided. Not necessarily that all the time permissions are provided, but there can be some chain codes that may require access to the state created or updated by another chain code. So remember that there are two perspectives, right? One is chain code for developers. So that is typically used by application developers to utilize the blockchain network. So here what we are doing, we are running an application on the network. Just like some people are maintaining the network and some people are running application on the network. Like I'm running an application which is Zoom platform on the network to have an interaction with you. But there can be chain code for operators. There has to be some chain codes for operators. They're oriented to blockchain network, basically to maintain the network, manage the blockchain network. So they would use the benefits of Hyperledger Fabric APIs, which are there. A lot of APIs are there to install and govern chain code, but they would not be involved in the development of an application. So just like system programs are there and application programs are there, here also we have the concept of chain codes, which are system chain codes and which are chain codes which are for application. So if I look at the Fabric chain code lifecycle, this involves managing the installation and defining its parameters. See, think about some chain code, you have to define, you may have to define what is the duration in which this chain code will remain alive. That is also possible because some business, for example, elections start from say June 21 to June 25. For that, some preparations may be required. So there are some chain codes which may contain smart contracts. Those will be only live from some time to another time, right? So we can say that it can be say June 21 to 25 until and unless all if after the election all the votes have been counted, all those things. So Fabric chain code lifecycle involves managing the installation and defining the parameters of a chain code before the chain code is actually used on a channel. In Hyperledger Fabric 2.0, initially chain code was not fully decentralized, but from Hyperledger Fabric 2.0, the governance of the chain code is fully decentralized. What does that mean? That means that multiple organizations can use the Fabric chain code lifecycle to come to an agreement on various parameters of the chain code. So what are those parameters? say, for example, one parameter could be endorsement policy. Another parameter could be for how much period this chain code will remain live. What will be the name of the chain code? Other various parameters which are there. So a network operator uses the fabric lifecycle to perform these 4 tasks. What are these tasks? First of all, install and define a chain code, which is very important. Upgrade a chain code whenever you need to upgrade. Now, unlike the previous smart contract, which was like a hardware device on a live network, which could not be changed. The only thing is that you need to bring a new smart contract and make the previous smart contract obsolete, right? Just like think of transformers in the electrical network. How do you change the transformer? How do electrical field operators change the transformer? There is some point of time for which the network is kept down and the transformers are changed. So it is not like the smart contracts in public blockchains are like hard devices on a network. So unlike that, here you can see that because you have pluggable services that are available. So what I'm intending to tell you here is this, that the network operator uses the fabric lifecycle to perform different functions. First of all, installing and defining a chain code. You can upgrade a chain code, right? Deploy chain code and migrate to the new fabric lifecycle as well. So let's see what requires to be done to install and define a chain code. First of all, remember that fabric chain code lifecycle requires that organizations agree to those parameters that define a chain code, such as name of the chain code, which version of the chain code, and this could be chain code endorsement policy and many other things. So then channel members come to an agreement using 4 steps. What are those 4 steps? Remember, I seek your attention. Tomorrow, when you will be doing this program on Hyperledger Fabric Network, you will be doing some of these things. So you will be packaging the chain code, all the smart contracts in one single chain code. You need to install the chain code on your peers. So channel members means there can be 2 organizations. They will be required to disseminate this to all the peers so that it can be installed on all the peers. Approve a chain code definition for your organization. See, without your approval, you will not be able to take part in any application or any business which involves this chain code. So you need to approve a chain code definition for your organization and then commit the chain code definition to the channel. So these are the 4 things: package, install, approve, and commit. But remember that not every organization on a channel needs to complete each step, because there can be organizations which have greater role to play in a network, and there can be other organizations that join later, and they may not be required to follow all the things. So let's take packaging smart contracts in the network. How do we package smart contracts in one chain code? So you have chain code package. You have a package label, my chain code 1, and here also package label my chain code 2. You have 2 pairs of OG1 and 2 pairs of OG2. So we would like to, the chain code is packaged separately by OG1 and OG2. So each organization will be responsible for packaging the chain code and separately. So both organizations use their package label, same label, to identify the package using the name and version. So what happens that if it is by convention, you can have your own name as well. It is not necessary for organizations to use the same package label, but just to keep in sync with other organization, by convention, we use the same name, same package label. All the organizations use the same package label. Okay. Then we install the chain code on peers. So first you saw the chain code is packaged. Then it is installed on each peer, as you can see here and here. All right. So org1 and org2 both are installing it on each peer. That is on each peer's computer. So a peer administrator from org1 and org2, they install the chain code package, my CC1 on peers joined to the channel. And then they install the chain code package, right? And once they install, this package builds the chain code and creates a package identifier. So the moment I install as an administrator, you will get a package identifier, my chain code, this some hash. So you can see that now the chain code definition is available to both the peers of the organization. And it is also of organization 1 and organization 2. So what happens that once the peer installs the chain code package on the administrator peer installs on all the peers, then that will build the chain code and create a package identifier for that, right? So this has become, so it approves basically the chain code definition, right? And then organization administrator from both the organization, they will be approving the chain code definition. And this chain code definition, what does that mean? It includes chain code name, number 1, what kind of, which version, is it updated version or the previous version, endorsement policy. Then there can be many other fields also. When in the lab, you will see that there can be many fields depending on the kind of application that we are running. So since both the organizations will be using the chain code to endorse transactions, remember that one needs to include the package ID, right? Because both, how will you identify that this transaction proposal requires this kind of endorsement policy? It will depend upon the package ID. So now then, once it is approved, then finally it is committed to the chain code, committed to the channel. The chain code definition is committed to the channel. So one is installing, packaging, and then installing. After installation, this package ID will be created. And then finally, it will be committed to the channel because both of them agree, both the organization members agree. So it will be committed to the channel. The moment it is committed to the channel, it becomes available. The chain code becomes available for running an application. So basically, this chain code definition is available to both the peers of org1 and org2, because everybody who is on the channel has the right to access the chain code. So this is the that you first package and then install, then approve, and then commit. Now, how do you upgrade a chain code? Can somebody tell? How can we upgrade the chain code? If somebody would like to write on the chat box, how do we upgrade? Suppose you need to upgrade the chain code. Anyone? If you raise your hand, I will definitely unmute you. Okay, so for upgrading a chain code, actually the same cycle is required. You need to follow the same steps: repackage, install, approve, and commit, right? All 4 steps are required. Just like I told you that a transformer has to be removed and a new transformer comes. So for upgrading, here it is a replacement that I'm talking about, but upgrading a chain code also requires the same process here, right? So upgraded chain code, now you can see that you have here, this is the chain code definition, my version 1, and you have like sequence 1, endorsement policy 2 of 2, you can see here. This is available. That means both the organizations must agree. Endorsement policy says 2 of 2. And now the chain code is upgraded. So when I say it is version 2, there must be some definition changes in the logic. That was the reason it is there. Now you can see that the chain code package, there was my CC _1 hash. Now it is repackaged. So now it is my CC _ and installed. So now you can see it is my CC _ 2 hash. So you can see that the package ID of the newly installed chain code or upgraded chain code is changed. And here again, the endorsement policy could be the same, is the second sequence, and so on and so forth. Now, suppose there is a channel in which there are 2 organizations, they are doing business, and in this business, a third organization also joins. So the third organization can be, let us think of a car company. The car company may involve the third organization who is maybe a designer, and the second organization which may be dealing with the batteries, and the first organization that was basically a car company, right? So you can be having one car company, the second battery company, the third is designers. So let us see how new organizations are accepted. So there can be different possibilities. Number 1, the new organization may approve the same chain code as committed by other organizations, right? So for example, if it is the matter of a car design, then the new organization and car company is important. Battery manufacturers may not be taken into loop, or the battery manufacturer also thinks that I should be taken into loop. Then all 3 endorsement policy may be saying that 3 of 3. Right, so the new organization may approve the same chain code as committed by other organization. New organization may not agree to the chain code as committed by other organization. And the organization on a channel do not agree on a chain code definition. It may happen. Like I'm saying, first of all, the new organization may approve, may not approve, right? But the second thing is that suppose it does not approve and it proposes a change. So channel organizations on a channel do not agree on a chain code definition, new definition, for example, for endorsement policy. Or another endorsement policy may be agreed upon by all the organizations. So there can be many things which are possible. So suppose organization 3 joins the channel and approves the same chain code that was previously committed to channel by org1 and org2. You can see the change here. The endorsement policy of this version 1 says 2 of 3, right? Here, the endorsement policy new organization joins and it accepts that endorsement policy should be 2 of 3, right? Here, you can see that the endorsement policy 3 of 3, 3 of 3. Now, why? Because perhaps initially it was written all the organizations in the channel, but now not all the organizations have joined. So it may happen that the new organization may approve the previous endorsement policy. So after approving the chain code definition, the new organization can start using the chain code after the package has been installed on their pairs, right? So the chain code definition does not need to be committed again, all right? If suppose the endorsement policy is set as the default policy that requires endorsement from a majority of channel members, then the endorsement policy would be updated automatically. Remember, if I say that it requires a majority, then 3 out of 5, 2 out of 3, that would be upgraded automatically to include the new organization, right? That will happen. So there are several possibilities, and my suggestion is that think about different cases, what could be different possibilities, how we can change it. So all this agreement, like how endorsement policy will be changing, is prior to somebody joining the channel. So you can see that unlike public blockchain where anybody can join, and so he has to conform to what is the current policy, or if he wants to make a proposal, change in the proposal, there has to be again a consensus for changing. So these are known as for example, in Bitcoin, several changes have been proposed, and these changes have been proposed by peers. These are known as Bitcoin Improvement Proposal, BIP, Bitcoin Improvement Proposal. Similarly, in Ethereum, you have Ethereum Improvement Proposals, right? There are several public networks where improvement proposals are floated on the network. If they get the consent of, I don't know, it depends on the network, of the majority of the network people, and with a high degree of probability they are accepted, then only those changes are made in the structure of the network, right? So chain code components, every chain code program is required to implement chain code interface. So what are the components? One is a smart contract. The other is a interface whose methods are called in response to received transactions. So chain code SHIM API is available basically for each of these languages like Java, Go, Node. So those who would like to develop, though APIs will help you ease your implementation task so that you can do it very well. Now, as I told you, that chain code could be for application developers, and a lot of new jobs are being created. I read somewhere in the reports that approximately 70% of the jobs that are being created are going to be floated in different parts of the world, especially the Western world, are related to chain code, related to blockchain. But most of these jobs are for application developers. For operators also, jobs are available. But chain code, from the perspective of a blockchain network operator, here the life cycle is slightly changed. It consists of the process of first packaging, because it is the operator's job who will be running the fabric network. Packaging, installing, the same as the previous one. But here, see, it is instantiating, right? So we are not committing on a channel, a specific channel, but on the network. We are instantiating and then upgrading the chain code within the blockchain network. So here, what is very natural that we do not require approval and commitment from the channel members. Here, only the operators who will be maintaining them will be doing it. So Hyperledger Fabric API enables all these operations. So one doesn't need to actually do it separately. You have several APIs that are available. I told you in the beginning that there's something called lifecycle system chain code. So lifecycle system chain code is a system chain code used in Hyperledger Fabric to implement several system behaviors so that they can be replaced or modified by the system integrator from time to time. So one may require, so suppose there are 5 organizations who are running their business on a Fabric network, and they think that there's something that requires to be changed. There's some kind of operation needs to be added. So accordingly, those things are added, implemented, depending upon what is the agreement of different members on the network. So system chain code is built into the peer executable, and it doesn't require install, instantiate, and upgrade lifecycle, because there's nobody who will be doing it. It will be just for running the network, you will be installing it. But remember that, again, it is a chain code. So suppose I and you have agreed and chain code has been accordingly coded, neither I nor you can temper any thing to change the network setting, because it is a chain code. Once it is a chain code, it is deployed on the system, on the network, nothing can be done, right? So all these things you need to remember. So most of the text in the slide that I've taken is already available in the official tutorial of Hyperledger Fabric Network. And my suggestion is that if you are interested, please go through the tutorial. It's a very vast tutorial. Whatever points that you wish to study, for example, how a network is made up and running, how peer organizations can be added, how peers can be added, how a smart contract, 2 or 3 or more than one smart contract can be bundled in a chain code. What kind of interface, how do we create the interface? So all these things, of course, are facilitated through APIs that are available, but my suggestion is please go through those important resources that will help you. So about 5-6 years back, when I studied this and for teaching a course to my undergraduate students, I was much benefited by the NPTEL lectures on Hyperledger by Dr. Praveen Jayachandan, although those lectures are now old. But looking at those lectures, I think you will get an idea. So I found those lectures quite useful. There is a course also in Coursera, but that does not, I mean, the course that I did long back did not involve Hyperledger Fabric. Most of it was based on the Go Ethereum. So this finishes part 1. Any questions here on part 1? If you have any questions, please feel free in asking. So I can do part 2 then. Any questions you have? No questions? Mekla says no. Srinivas Rao also says no. Okay, then I will be sharing the other slide. Thank you so very much. I will be sharing the other slide. because I thought that we need to also discuss, although people have discussed about the security and other things of blockchain, something which I find is very important is secure multi-party computation, which is a very interesting part that has emerged recently with chain code. It was already existing in the literature, but its importance was felt with blockchain, not chain code, with blockchain. So today we shall be also talking about secure multi-party computation. What is this? So let us begin with introduction to secure multi-party computation, and then how it can be used for blockchain security. So you must have heard, how many of you have heard that Bitcoins were stolen, account was hacked, and there was some security breaches? Any news that you have read, please let us know about Bitcoin security. So Abhishek Patel says and Shankaran says, they say that yes, they have heard. So what you have heard, if you go in the depth there, you will find that it was basically the carelessness of the person who lost his key, private key. So let's begin with this. So blockchain security basically relies on the public key cryptography. And public key cryptography does what? For you, there is a public key and private key. Public key you share so that other people are able to authenticate any document or message sent by you by trying to find out whether this has come from an authentic person or not, using your public key. And you are encrypting the message using your private key, right? So, and there are some hash operations that are performed, and we have had excellent lectures on these. So basically, you have public key cryptography that plays an important role. And in this, key management is very, very important for maintaining the blockchain account. Just like your email account, if you forget the email password of your email, you will not be able to access the account. If somebody hacks your email and changes the password, you cannot use that account. Or somebody hacks your password and starts sending mails, making transactions, then also it will not be possible for you to stop him. So while blockchain data is securely and immutably stored, remember, every single transaction, whether it is a malicious transaction in the sense that somebody has hacked my account and he is doing transactions, but if that transaction is found legitimate, then that will be recorded. So what I intend to say here is that while blockchain data is securely and immutably stored, attackers can gain access to the data by gaining access to the private key of an account, right? So they can gain access on your private key, and they can, steal all your cryptocurrency. That can happen. So blockchain security, how secure multi-party computation plays a role in blockchain security, and how it so happened that why people found that attention should be paid to secure multi-party computation for the security of the blockchain. So secure multi-party computation is what? It has something which is very, when I say multi-party computation, so that means there are several parties which are making computation. So it is a kind of decentralization, right? So Basically, the idea is aligned to decentralized and distributed model of blockchain, and that is why secure multi-party computation is found to be very useful here. So basically, it's a cryptographic technique designed to secure digital assets or protect information cryptographically. So what is secure multi-party computation? You do multi-party computation in a secure way because cryptography is associated. So multi-party computation means what? Jointly, people are computing the output of a function that depends on, remember, I seek your attention, please, on private inputs of multiple parties. Private inputs of multiple parties. These inputs are not disclosed with other parties. So each one gives his share, and finally an output is computed. That outputs is computed serves the purpose of a further work or function. So what is secure multi-party computation then? That deals with multi-party computation with an added factor of what is known as zero knowledge proof. Zero knowledge proof, right? So zero knowledge proof is what? Let us consider this example. Suppose Alice, who is a prover, wants to convince Bob, who is a verifier, that a statement X is true. Think of any statement, that some statement is true, right? So I'm prover and you are verifying it, right? So let the statement be 2351 is a composite number. So suppose I have to prove to you, to show to you, which you will verify that it is really a complex composite number or not. So what I will do? Can somebody tell what I will do? And what will you check? What I will do and what will you check? How will you check that? Yes. Anybody who can tell me how will I prove and how will you be convinced? No answers? What is yes? Factorize the number. So Priyanka, Dr. Priyanka says factorize the number. So you mean to say that I will give you the factorization and you will check whether those factors are correct or not. Am I right, Priyanka? Right? So what she says is correct. What I'll do that, yes, I will, as she said, check prime condition. Dr. Shalini Ninoria says check prime condition. Well, it is more difficult than checking that there are factors, because prime condition, it is prime or not, you will have to look at all the numbers less than certain value, root n or something, and then see whether they are dividing this number or not. But finding out the factors is easy. So what Srinivas Raoji and Priyanka Patel says, right? So traditionally, Alice will show that 2451 is equal to 3 into 817, or 19 into 129, or 43 into 47, right? But then Bob will not only be convinced by looking at the factors, verifying himself that X is a composite number, but will gain the knowledge about the factors of X. I hope you understand that he is, while convincing, I have given you the information also that this is how this is a factor and this is a composite number. Now think of a scenario where you are signing in your account And on the other side, the server checks for your username and password. That is placed somewhere on a central server. That password checking, if you know, passwords are not saved like plain text. They're saved in a encrypted or they're salted with something so that the password cannot be, I mean, even if there are, so Sunil Kumar Jha is saying 2351 has a two factors. I think I wrote by mistake 2351. Sunil ji, you are very right. You are proving that I'm wrong. So that's very right. This number is 2451. It's not 2351. It's 2451 as I wrote here. So please correct it 2451 because 2351 is a what Dr. Sunil Jha says is really a prime number. It has only two factors, itself and one. So what I wanted to tell you that if I have to show that it is my email account, so I should also show you my email ID as well as the password. That is the knowledge that you will gain. Right now in the server, of course, the information is given that I'm using the right password and the system checks that you are using a right password, but the password that reaches the system is an encrypted password, right? So the system checks and finally approves that your password is correct. So in zero knowledge proof or ZKP, if suppose Alice has to show that this is a composite number, Alice will be able to convince Bob that X is true, the statement is true, but Bob will gain no information or zero knowledge about it. That is what is known as zero knowledge proof. So naturally, if there is a zero knowledge proof, it cannot be a deterministic way of proving it. Let me take this example. So let me first define what is a zero knowledge proof. A zero knowledge proof is a method by which the prover can convince the verifier that a given statement is true without revealing any additional information. So I show to the system that I'm using the right password. I show to the system that this is my email ID by actually logging into the email ID without the system gaining access to my password. So method by which the prover can convince the verifier that a given statement is true without revealing any additional information, that is known as a zero knowledge proof method. Remember that zero knowledge proof must have certain properties. First, completeness. I seek your attention, please. What is meant by completeness here? By completeness, I say that if a statement is true, then an honest verifier will be convinced that prover possesses the correct input, that is the knowledge or the information, right? The statement is true, then the honest verifier will be convinced. If I use my password without revealing the password, if I use my password to gain access to the email account, then if the verifier is convinced that the password must be correct because something is matching, right? Some condition is satisfied. So what he tries to claim that it is his email ID so that he can be given access or he gains access using certain method, then honest verifier, as I said, will be convinced that the prover possesses the correct input. That property is known as zero knowledge proof. So if you wish to develop any method for zero knowledge proof, then you must show that this method is complete. The second thing is known as soundness, second property. Soundness means if a statement is false, right? Suppose I'm trying to prove that this is my email account, aojha@iitdmj.ac.in is my email account. And if suppose that statement is false, then no dishonest prover can convince the verifier that they have the correct input, right? That means no incorrect statement can be proved using, or no incorrect output can be obtained using the zero knowledge proof method. These are two important properties, completeness and soundness. They must have, a zero knowledge proof must have these essential properties. The third, which is very essential, is zero knowledge, that if the statement is true, then no verifier, if the statement is true, then no verifier learns anything other than the fact that the statement is true, right? So 2451 is a composite number. No verifier will be able to learn anything other than that the 2451 is a complex number, right? Let me give you an example from taken from Wikipedia, Alibaba cave. This is a very old example. So suppose there are two people. One is a prover and the other is verifier. The prover says that I can walk along this cave through path A or path B. And whatever path you suggest me to come out from, I will be able to come out from that path, right? So Peggy randomly takes either path A and path B, and it is Victor who has to verify whether he can come out from any path or not, knowing that here it is likely that the paths are not connected. That means there is a door which is closed. So Victor may not be having any information about how Peggy will manage to come out from path A or path B. Like you must have seen many magicians sometimes give you a set of cards and ask you to think of any card, and then they show you the card. There is something which is related to this. There is a zero knowledge proof. You know that magician has the knowledge that he can prove something, and you get convinced, but you have no idea how does he do it. So Victor chooses an exit path for Peggy. Peggy goes through a path, and then Peggy exits from the gate which is chosen by Victor, right? So what is this? Zero knowledge to Victor that the Peggy has the key to the internal door, right? Or Peggy has the route by which he can follow to come out of the come out of the cave from any direction that Victor suggests. So that means Victor knows that Peggy has the knowledge, has the correct input of coming out of the from a specific path, but he himself does not have any knowledge as to how to come out of path A or path B if you randomly select any path. So this is known as Alibaba cave puzzle. So as I told that probabilistic assessment is done in zero knowledge proof. So zero knowledge proofs are probabilistic assessments, like the prover will keep on proving n number of times that I have got this knowledge, and therefore I am able to produce the output. And verifier will verify n number of times. So maybe 99.9% accuracy you get, the prover will get, and so the verifier will get convinced. So they don't use deterministic methods to prove something that reveals the complete information. Rather, they prove unlinkable, they provide unlinkable information that can be pieced together to establish a high probability of the validity of an assertion, right? So here, what is very important is that there are unlinkable information. When they are pieced together, then you get that the assertion is valid, right? So sometimes in the banks, when we go to our lockers, then the manager has a key, we also have a key. Both of us give our inputs, use our keys to finally open the locker. So basically, it's a multi-party computation that is done to open the locker. But if you did not know about my key and I did not know about your key, and then both of us are simultaneously putting our inputs and the locker is opened, then we know that, okay, this multi-party computation can be done to arrive at an output or validity of an assertion. So secure multi-party computation. Now I come back to this. So suppose Alice has a private input X and Bob also has another private input Y, and they want to know the output Z that is obtained as Z is a function of X and Y without knowing each other's input, right? So without knowing each other's input, both of them would like to do a computation. So example, many parties wish to execute a private auction. See, whenever some auctions are there, everybody will be putting his bid in a sealed envelope, right? And the highest bid wins. How do you know that this is the highest bid? You have no idea. You know the highest bid was, say, somebody, there is an auction management company who will be basically opening all the bids and then will announce that this is the highest bid. So you will have to trust, right, that this is the highest bid. And they are trusted third parties, right? They are trusted third parties. People have trust on them, and therefore people are participating in the auction. So you know what is your input. You know what is the highest bidder, because that is announced, highest bid and the winner. So others, what they have quoted, we have no idea. You might have quoted just ₹1 less than the what is bidded by the highest bidder. So everyone wants to know only the highest bid and the winner. Another example is that you have intelligence agencies of different countries. You know that many a times we keep on having a conflict with our neighboring countries, specifically Pakistan, that he's a terrorist in our list, and you are giving him a different treatment. And so people would like to know from different countries that what are the common persons in the list of terrorists, but they would not like to reveal the list that they have. So they want to know the common names, as I said, in the list, but do not want to reveal the list. This is one example. Another example. So here, what is important in multi-party computation, that there is a third party. This model works well in these examples, right? There is a third party. But remember that in blockchain applications, trusting a third party is a strong assumption. Like we are right now trusting our server systems, which can be hacked anytime. So all the passwords can be stolen, right? So we are basically, and the server may be, you have redundant servers so that your passwords are not protected, but there can be a time when somebody can hack. You have heard several stories of hacking of so many identities of credit cards or many other things that you must have heard about. How this has happened? Because some servers were hacked and therefore information was leaked, right? So a trusted third party is a strong assumption. And therefore, the decentralization method that is used in blockchain technology can also play an important role here. Give me a minute. Let me just give me a minute, please. Thanks for waiting. I'm sorry I was feeling thirsty. So in multi-party computation, a trusted third-party model works well, but not always. So if I look at the trusted third party, it's a very strong assumption. And therefore, as I said, that in ideal world, third party is possible, but not in the real world scenario. Anything we cannot trust here. It's a trustless environment, digital world. So can there be a solution with the same security and fairness and with a guaranteed output? Remember that if we say that if I'm proving something, you are verifying something, the same thing, and this should not go into a loop. There has to be an output, right? So with a guaranteed output without using a trusted third party, is it possible? So the goal is to use a protocol to emulate the trusted third party, which is important, right? So in multi-party computation, it works on the assumption that the concerned parties can communicate on a secure and reliable channel, number one, right? Parties possess pieces of information that, when we combine, can reveal a secret, sign a message, or approve a transaction, right? Reveal a secret, for example, the locker is opened, sign a message, like, you know, that whenever we sign a message or a document. So, for example, registry of a house is changed. The name of the owner is changed from A to B. So what we do is that we sign, they sign, and then finally the the house's ownership is changed. But this is all revealed. Without revealing, is it possible that you sign your bid, they sign their own stuff, and then finally the owner is changed, or approve a transaction? So basically, there is something which is a function of x1, x2, x3, x4, where x1, each of these x1, x2, x3, x4 are input to this function. Function has these 4 arguments, and the function provides its output. So the output of a function is obtained by taking the input of all 4 of this, right? So this is what is multi-party computation. If I look at the origin of multi-party computation, my dear friends, it was around 1982 when a Chinese computer scientist and a computational theorist, Andrew Yao, introduced this concept of multi-party computation. Basically, around the same time, if you see in the history of computer science, that networked systems, distributed systems, basically not network, distributed systems, the idea of distributed system was taking shape, it was evolving. So how distributed systems can be effectively used. So many different ideas were evolved, and this was one of the ideas. So allowing 2 parties to jointly compute data without revealing inputs. So he popularized the multi-party computation by introducing the millennials problem. So basically he introduced and then he popularized the millennials problem. What is millennials problem? So 2 people go on a dinner, and they offer that they will be paying for the dinner, and both of them claim that I'm richer, so the lunch is not dinner, but lunch. I'm richer, so lunch is on me, right? So how do I don't want to reveal my net worth. You don't want to reveal your net worth. I don't want to reveal my salary. You don't want to reveal your salary, but you would like, both of us are claiming that I'm getting a higher salary than yours. So I'm throwing a question to you, my dear participants. How will you solve this problem without both of them? I mean, they don't want to tell that their salary, they don't want to tell about their salary to the other person. Any suggestion? So some suggestions. Zero knowledge proof technique, Neetu, but what technique? Tell me. How will you prove? I'm asking that. So let's take this simple example, right? So I and my colleague, both of us are working in a company, and approximately the same. Oh, that's great. Shrishti Devare says they select a random number and each person tells if his salary is greater or less than that. Yeah, very something. What you are saying is, if you try further, I think you can get the solution. So let's take a very simple example that 2 people are working in the same company and they want to know their salary, but because the company does not disclose the salary of other employees to an employee, so one can do like this, that suppose my salary is say 40K, maybe close to 40K, close to 50K, close to 60K. close to 70K, right? Okay. So you can accordingly, if it is say 45 and above, it will come this way. If it is below 45, then it will come this way, right? So there are 4 boxes and a slit, right? Each person comes one by one, person come, and he takes the key of, so this box is 40K, 50K box, 60K, and 70K. The person is asked to write yes, so to put the slip of yes or no on this slit, on this box. But the person whose salary is suppose close to 60K will be having key of this box. So he takes key of this box and you take the key of say this box, right? So Alice takes key of this box and Bob is having key of this box. Okay, so Alice will write what she will do. Alice will write, for example, no here, yes here, no here, and I hope I'm doing right, and then no here. Bob will write here, yes, no, no, no. Am I right? Bob will write yes here. Now tell me, if both of them have the key of their respective boxes, when they open the box, they will be getting this information that the salary of Bob is not equal to salary of Alice. Both of them will be getting this information, right? The salary of Bob is not equal to salary of Alice. Now, from here, do they get any information? Do they get any information? How do I modify this experiment that they will be getting the information? So what Shruti says, choose randomly, say number 55. If your salary is less than 55, you write yes. And if your salary is not less than 55, say no. So what will happen that in that case, out of the, I'm purposely, I put here 4 boxes. If I write here these 2 boxes only, so what will happen? The moment Bob opens and he says no, sees no, he knows that he is richer than Alice. That means his salary is more than that of the salary of Alice, right? So what I intend to say here is that through this fun type of method, Andrew Yao tried to popularize the idea of multi-party computation. All right. So the main components of multi-party component, I seek your attention, please, on this. The main components of multi-party computations are that the private inputs of parties to obtain the combined output cannot be revealed. I mean, by no method, one should be like in puzzle, jigsaw puzzle. If I have the component and you have the component, and both of us put together the component, so we will be able to solve the jigsaw puzzle. But I know that what part you may be having, right? So here, by giving an input to the function, from the function output, it is not possible to infer the input of any given party, number 1. Number 2, correctness. The output obtained is always correct. If the parties have given correct input, the output is always correct, and parties cannot manipulate to produce an incorrect output, right? Other security requirements also include independence of inputs. So a party's input is independent of other parties' inputs. Fairness. If one party learns the output, then all parties must learn the output, because it should not happen that malicious nodes are getting the output and honest nodes are not getting the output. Guaranteed output delivery, that all honest nodes must learn the output, right? So it should not happen that some of them are not getting the output and some of them are getting. There is fairness. Guaranteed means one should not keep on put on loop that the output is never revealed, right? So all these are important things, important properties of multi-party computation, which is secure. There are certain use cases like genetics testing. Let's see. I would like to use my gene sequence to find out what is my risk of any disease. So people can check their own genetic profile without revealing to hospitals or medical insurance companies about their caffeine metabolism, or if their genetic profile is likely to develop any chronic disease like diabetes or hypertension or any other thing. Similarly, another use case you can think, hospitals do not wish to share their patients' records, but want to combinedly, they want to data mine for sensitive research, just like COVID-19. There was some sensitive research where we wanted to have outputs quickly for getting a cure from COVID-19. So companies would not like to share their data, but they would like to combine their research activities to reveal and to finally get an output. So there are several use cases which exist from e-commerce platforms like Amazon, Amazon, Flipkart. They may be using simultaneously some data, but they would not like to reveal their data, right? Game networks. Remember that game networks is a very flourishing industry where several people are using combined efforts to win a game or to what should I say, to lose as a small amount as possible. So all these things are examples where, all these use cases are examples where one can use secure multi-party computation. Now, how secure multi-party computation can be used for blockchain security? This is something very important. So, private key management is very important task, as I told you in the beginning, that in public key cryptography, if your private key is stolen, everything is stolen. So loss of private key can result in the loss of or theft of digital assets or information. As a result, in Bitcoin blockchain and many other cryptocurrency blockchain networks, people are using hardware secure modules. These are like USB devices, right, which are known as cold wallets for key management. So they store their keys in this. Unless you plug in, nobody will be able to, what should I say? Nobody can access your account without those hardware keys, like the toggle keys or and dongle keys that we get. So hardware secure modules are used for key management, but they have several limitations, lot of limitations. Some of them I have listed here, right? Like physical upgrades are expensive. Then software updates are manual. So every time you have to manually update the software. And for using those hardware keys, there are certain pins. So suppose you have lost your pin, then you cannot use a hardware secure module. So these are important things. They are known as cold wallets. Then because of these cold wallets, we don't have issues with cold wallets. They are, I would say that blockchain itself, the security, the private key management is difficult task for people who are using millions and millions of USD for, I mean, they're having millions of USD for on the blockchain network, Bitcoin blockchain network. So private key management can be done using SMC, and people have devised method. There are a lot of research papers in these directions. The private keys of a crypto wallet are fragmented into segments, which are known as shards, and shared with other nodes in such a way that any function to be performed, for any function, you need a minimum number of nodes, which is known as similar to threshold signature scheme. Holding key shares must, minimum number of nodes holding key shares must be involved. So threshold signature scheme is again a centralized way, because there what happens that all are combined together, and finally they're used to verify your signature. That is a threshold signature scheme. But here the protocol ensures that any dishonest node should not be able to attack or tamper data unless they reach the threshold for signing transaction. So many of you must have also seen that there are visual secret sharing or secret sharing schemes where there is a threshold which must be crossed to reveal the secret. So a secret is fragmented into n number of pieces, and out of those n number of pieces, if there are k pieces which are joined together, then that gives you the secret, right? So it is something similar to that, but here one important thing is that in the blockchain network, this is a completely decentralized process. So these nodes have no information about who all are having key segments. So it is not possible that they reach a consensus, or they can combine their efforts in stealing. So dishonest nodes should not be able to attack tempered data unless they reach the threshold. So because they have no idea as to who all are having the key fragments, therefore it is not possible that they will be getting the private key. So a lot of people are promoting this idea of using SMC for this. So let me give you an example taken from some source of how private key management is done. So suppose Alice, Bob, and Cynthia, all of them would like to know, as I told you, about their salary, who is getting more, who is getting less, whether I'm getting less than the average employee salary or not. So they want to find out the average salary of their employees, at the same level. So you know that the Alice here is getting $100 per hour. Just a minute. So Alice is getting $100 per hour. Bob is getting $12 per hour, but Cynthia is getting $22 per hour. What they will do, they will break hourly wages into 4 segments. Like here, 11 is fragmented into 2, 1, 4, and 4, right? So 8 and 3, 11. Similarly, Bob's salary, he fragments randomly into 4 segments, 4, 2, 4, 2. So you can see that this is $12. And similarly, Cynthia will be also fragmenting into 2, 4, 6, and 10. So now what they will do, they will be using a trusted third party. to calculate. And this trusted third party is basically your contract or something, a program which is written to find out, average salary of this, right? So think of this trusted third party is not a manual trusted third party, but here let us assume that this trusted third party is there. The trusted third party will also not have any information. So here you can see that green control. Sorry, just a minute. Okay, so you can see that this is green, this second green, and the third green. All this will be shared with Alice. Red, the second red here, that is 1, 2, 4 will be shared with Bob. 4, the third 4 here, and 6 will be shared with Cynthia. And the fourth part that is put in black, 4, 2, and 10 will be shared with a trusted third party, right? So you can see here that Alice is having 242. She takes the sum of that. Bob takes the sum of the whatever he gets. Cynthia takes the sum, and the trusted third party also takes the sum. And then all of them will be then dividing by 3 to find out the average. So 8 by 3, 2.7, 7 by 3, 2.3, 14 by 3, 4.7, and 16 by 3 is 5.3. And then they will be adding, right? So this will be added. Everybody has given his input, 2.7, 2.3, 4.7, and 5.3. None of the parties are able to get any information about what is the Alice part, what is the Bob's part, and what is the part of Alice, what is the part of Bob, and that of Cynthia. They are only giving this information, right? So finally, the 4 outputs are added and you get the average output. So this is a method of secure multi-party computation for computing the hourly wages. You can see that after looking at this hourly wage, which is a average hourly wage of 11, 12, and 22, you can see that is the average is 15. And Alice will come to know, okay, I'm getting much less than other members. Bob will also think, but Cynthia will be happy that I am getting much above what others are getting. So this is one method of, and in a very simple way I have explained here, but secure multi-party computations are having a very robust and secure algorithms for computation, for revealing the output, so that no input is revealed. So like Byzantine fault tolerance, multi-party computation system need to consider that certain parties can be dishonest, right? There can be adversaries. So it has to deal with adversaries. So implementation complexity of multi-party computation is directly proportional to the type of adversaries. There can be semi-honest or malicious. What is meant by semi-honest? This is a very nice paper. Now I have given at the end of this slides the reference. So multi-party computation is directly proportional to the type of adversaries. By semi-honest, I mean that somebody is curious to know what could be the input of other party without actually trying to do any harm to the other parties. They would be curious in knowing the inputs of other parties, right? So by guessing by something, they would like to do it. And there is an adversary which is who is getting the works done by these semi-honest people. So you must have heard that in terrorism also, what happens that people are employed for some task and they do not know whether that task will lead to such a devastating effect of terrorism, after effect of terrorism, right? So they may be having some incentives in terms of monetary gains or other incentives, but they do not know that they are actually harming somebody. So these semi-honest parties are basically unintentional, curious parties who, on behalf of some adversaries, are doing it. Or it can be malicious also. So malicious, we know that they have information that they are doing wrong, but they keep on doing this. So for details of MPC signature scheme, I must give you this access to, I must tell you that this is one wonderful site. Let me just give you an idea. So this is a threshold signature GitHub page where a lot of information, multi-party threshold schemes are discussed, and you can elliptic curve digital signature algorithm. This is what is written here, like how this is, they have explained in detail for those who are interested in going through the details. The set of responsibilities of library layer and all those things, signature schema, key generation, signing and verification. So ECDSA algorithm consists of 3 algorithms, basically scheme, generation, signing and verification. And then they have also discussed about the execution model in detail here. And then they have given the code as well. So this is a good site. I found this site to be very useful. You can also refer to this site if you wish to work further on multi-party computation. This is a very good resource on secure multi-party computation by Lindell. And then this is another book and lecture slides by Ron Cohen of Tel Aviv University are also very wonderful slides, very well explained. And then I also found this introduction to MPC for key management protection. This article you will find is very useful. There are other important this. For algorithms on zero knowledge proof, you can go to this Stanford University website, where this is a very good, very useful resource that you can get on zero knowledge proof. So this is all for today's lecture. If you have any questions, please feel free in asking. So Virendra Kumar Thakkar is raising hand. Oh, sorry. Virendra. So, yeah, please, you can unmute yourself.
Yes, madam. Thank you.
Your voice madam, is very low. Just a minute. Let me improve my. Just a minute. Give me a minute. Yeah.
Yes, I have turned off my fan.
No. I had kept my volume low, so yes, please.
Okay. My fan was on. Okay, madam, I am assistant professor in computer science and engineering in CBP of Engineering and Technology, Pauri Garhwal in Uttarakhand.
Oh, I see. Very nice. Very nice. I have visited your institute, right?
Yes.
Yeah. So beautiful madam, campus. Yeah.
Yes. It is in hilly area, a very cool place, just like a hill station. I would just like to give some example from practical life other than cryptography, where we use the zero knowledge interactive protocol. One example is these answer books of students that we are evaluating. So what they do is they do the coding. And while evaluating, we don't know who that student is, because we are supposed to evaluate what is written rather than who is writing it. And after
Yes.
we return our evaluated answer book, then we get the decoded sheets, so that there should be no bias on the basis of, say, caste, religion, gender, region, etc. So that is one example of, say, zero knowledge interactive protocol that we are using in practical life, where without knowing identity of the students we are evaluating. Second example is, say, what the scientists do while testing, say, in like institutions like CCMB, Center for Cellular and Molecular Biology, Hyderabad. So while they do this DNA testing, paternity testing, so they are just given sample A and B, and they don't know whether this is ordinary person, whether that is a VIP, whether it is civil case, property case, criminal case. So they just say that whether it is samples are matching or not, and the outcome they inform without knowing the identity of the person. So this is we can say some traditional areas where we have been using this zero knowledge interactive protocol to hide the identity, or making it say anonymous or pseudonymous, and then these results are added. Another thing I would like to share is related to this
so here,
COVID.
Dr. Thakkar,
Yes.
one thing we must understand here, that the zero knowledge proof that we are using is definitely used from ancient time. But then there is a trusted third party.
Yes.
You know that there is a hospital which is having all the information. So its server can be hacked anytime. Or the person who is the technician can give you the information that this is of a VIP, or this is of your relative, your own relative, your wife, your husband. So that is very much possible. Likewise, if you see, whenever we find out the answer sheets of people, students, suppose I'm teaching to 25 students and I'm taking 4 tests. So sometimes we are teachers, we know the handwriting styles. Yes. So by looking at the handwriting styles, we tend to guess that this could be of, say, Sumit or Anita or Savitri or woman, whatever. So what I intend to say here is that zero knowledge proof means absolutely zero knowledge proof, where the person can only have a probabilistic understanding of, okay, this probably you know the answer and nothing else.
Yes, yes.
Right.
And thank you, madam. And one more thing that I remember from this COVID example that you have given. See, there was very much shortage of COVID testing kits. So what the scientists used in 2019-20 was that they used the pool testing. That is, they just combined samples of many different say people, and by combining the different samples, they found whether it is say positive or negative. And after that, they broke that sample into different say small sizes, and thus by using optimum use of say we can say using statistical techniques, that they saved a lot on this testing, because even these tests were not so reliable. It was just around 70%, and there were problems of false negative, false positive. So depending on which testing is more say, less harmful, and which is more saving to the say, for optimum say, utilization of our testing kits, they had used this pool testing in many hospitals. Thank you.
Yeah. Thank you for giving your inputs on this. Any other person who would like to say anything? If you have any questions or inputs. So if there are no questions and no suggestions, we will be meeting tomorrow, the same time, 10 a.m. My request to all of you is to please join before 10 so that we can start on time, because those who have joined should not be penalized for joining on time. Some of you join very late, so you miss actually. And tomorrow is 22nd of June. We will be having Dr. Suel Namsudra from NIT Agartala, who will be speaking on emerging applications of blockchain in healthcare. Probably he's speaking on healthcare. And then we will have an afternoon session on secure asset transfer on a hyperledger fabric network. With this, I thank you all for your patient listening.